everybody. My name is Stephen Roselle. I'm a technical specialist at Autodesk. We're actually sponsoring this session, so I just wanted to say a couple of quick words. I'm actually not going to be up here for long. I'm going to hand this off to Jeremy, but wanted to do a basic introduction, but also just to say that I will be here if you have any software-specific questions that are more Autodesk-centric, that aren't necessarily related to what Jeremy's going to be talking about. I'll be here to help answer questions. But for now, I'm going to introduce Jeremy Ernst, who's a character TD at Epic. He has a long history of character rigging and working as a technical animator, working on games such as Condemned 2, Bloodshot, Shadow Complex, and then Gears of War 2 and 3. And so today's talk is going to be focused on Gears of War 3 and the animation pipeline. I just want to point out, being from Autodesk, of course, that they did use Maya, Max, Motion Builder, and Scaleform. Motion Builder, correct, right? Yeah. Motion Builder and Scaleform. So they used a wide array of our products in development, but Jeremy's going to focus on primarily Maya and the animation pipeline. So without further ado, I'll go ahead and hand it off to Jeremy.
Well, that took up 2 minutes of my introduction that I had planned, so crap. But anyway, yeah, we're going to be talking about building a better pipeline, specifically for the rigging tools and the animation pipeline for Gears of War 3. And I do want to thank Autodesk for bringing me out today to talk to everybody. One of the things that wasn't said was that we actually at Epic use a lot of Autodesk technologies in our engine, the Unreal Engine, like Scaleform, Grip, Kinapse, and Human IK. So thanks again for bringing me out. And we have a lot to cover, so I'm just going to get right into it. I started at Epic in 2008. It was during the production of Gears 2. And it was an interesting time because I didn't have a lot of opportunities to change what was there currently, but I got to observe the pipeline that was there, if you could call it that, because it was a very small team, very small company. Gears 1 was made with a surprisingly small team, I think 30 people or something. And Gears 2, they were just starting to ramp up into a bigger company, but a lot of the mentality was still small team, indie little game. And so the animation team, for example, was 3 or 4 animators. They were actually split between Maya and Max. So we didn't even have a department that was in one program. So for Gears 3, my big goal was to make a cohesive pipeline for the rigging and animation tools, to make their lives easier, to make our department more efficient, but also to get all the animators inside of Maya. So I wrote all of the tools that we're going to talk about in Autodesk Maya 2009, and they were all in MailScript. Python had come out in Autodesk Maya 8.5, I believe, but it was too early. I wasn't that comfortable with Python yet, so I just stuck with MailScript because I'd been using it for a few years. Our general character content pipeline looks at something like this, where, and this is probably pretty similar for all studios, but our modeler gets a concept. The interesting thing is that our modelers are actually in 3ds Max. And I know that most studios tend to have their modelers and their animators in the same package. So it does introduce some interesting problems. Luckily, with FBX, we're able to get the meshes from Max into Maya, where I place the joints, do the skin weights, and the rigging, and then hand it to the animation team to animate in Maya. So these are 4 tools we're going to talk about, and I want to set some expectations because I'm not going to go into how to make the tools or anything like that. What I am going to talk about is what the tool does, where it fits in the pipeline. Oh, I didn't. Oh, no. Yeah, totally. All right, you know what, though? It's cool. Okay. Well, I only got into this slide anyway, so it's all right. Anyway, the general character content pipeline was modelers get the concept, they model it in 3ds Max. We use FBX to bring the model from Max into Maya where it's, the joints are placed, skin weights are done, the rig is made, and then I send it to the animation team who also animate in Maya. So for us, it's a little bit unique, I think, because our 2 departments are a little bit split between packages, but FBX does allow us to work and get our jobs done. There are 4 tools I'm going to talk about, and like I was saying, I don't want to set the wrong expectations. What we're really going to be doing is looking at what these tools do, where they fit in the pipeline, and then really taking a critical look at them, basically bashing my own work. And I want the takeaway here to really be lessons learned from my mistakes on the Gears of War 3 pipeline. So the first tool was the joint mover. And the joint mover is basically, if you're familiar with Character Studio Biped, Biped is a cool thing called figure mode, which allows you to place your biped in your mesh really easily. And I wanted something like that in Maya, so I made this joint mover, which is essentially a control rig that allows you to translate, rotate, and scale joint chains quickly into your mesh, and then you can mirror your changes from side to side. And also, whenever you move a child joint or child rig control, the parent auto aims at it. And then there's also offset control so that each individual joint can be moved without affecting the children, very similar to the insert key with Maya's default joint tool. So here is a look at that video. Looks like there's some artifacting. But anyway, so you can just scale, move, and rotate all these chains around. You'll notice as I move the calf around, the thigh offset mover is aiming at it. This ensures that our joint orients are always accurate and what they should be. We can mirror those changes from left to right. So it allows us to basically place our bipedal skeleton and our biped meshes, within just a few minutes. And our skeleton maintains the joint orients that we need for our engine as well. And then when you're done placing all of these, you can actually just hit the destroy button, which leaves you with your skeleton ready to do your skin weights on. So that's the joint mover. And there wasn't really a lot of problems with this tool. We still use it today. But I wanted to bring it up because I want to show where it fits into the pipeline later on, because I think that part's important. The auto rig is the next thing we're going to talk about. And I'm sure, as most people are familiar with what an auto rig does, it allows you to quickly auto rig some kind of template very quickly. So for us, we had something like 80 bipeds in Gears of War 3. Obviously, making those by hand would be out of the question. So there's an auto rig that will rig the bipeds with minimal setup consistently every time. There's a character picker UI with it. And one of the big features that the animation team likes is that with 2009, they had the animation layers got introduced. And so I wrote a function that allowed the animators to import mocap directly onto the animation rig controls that they can then put into an animation layer and polish from there. Before 2009, I had to either build in a built-in layering system into the rigs, and that was kind of very limited. With the animation layers, we were able to just do the mocap onto the rig controls, and the animator can polish from there. This last point, if you're familiar with Unreal, you'll know, and if you've been using it for a few years, you'll know that we used to have an importer tool called ActorX, which was an Unreal proprietary format. And the reason I bring this up now is because nowadays, within the last 6 to 8 months, we've switched to FBX, which has made our lives a lot easier, and I'll get into that in a minute. So here's a look at the auto rig that was written back in 2008 for Gears of War 3. You'll notice here that right now it's building. I didn't want to speed up the video because I wanted to show the faults of this as well. So right now, in my opinion, the build time is slow. You could say that the build time is fast for building a rig. 40 seconds is pretty sweet to build a rig. But the fact is that this tool is for the animators. And if it's faster to open a file than it is to build the rig, then they should probably just open a file. The other thing is that the character UI, while I think it's a prettier UI, the functionality isn't that great. For instance, when you want to use any function on the UI, you actually have to select a control on the character first to let the UI know who to do the functions on. So to simplify that, to use a character picker for a character, you have to select a control on the character to then use the character picker. So obviously, that sounds insane. But you have to keep in mind, a lot of these things are written on an incredibly tight deadline. When I said I want to make a big rigging tool suite for the project, they're like, okay, cool, you've got a month. And you're like, all right. So this is what you get. And right there, I actually just imported mocap onto the rig controls. And so now all the controls have the keyframes and things like that, so you can edit from there. The UI, as you notice, as I expanded those frame layouts, a scroll layout appeared. So now if you want to go back and select the head, you have to scroll back up. So I really, there's a lot of things here that could be improved. And I think being critical of your work like this is essential to making a better pipeline for future projects. So obviously, these are just kind of some points to reiterate the things that were said in the video. The rig build was really slow. It was 40 seconds. And I think a lot of that had to do with how the script structure was planned out. When I was writing the Mel scripts, I thought it'd be a great idea for each build component to be in its own Mel script file. So building the left arm FK is in the script file. Building the right arm FK is in a separate file. And I thought that was smart, but the problem is that when it goes to build all that stuff, it has to load all those files in, and that takes a lot of time. So that's where all that time comes from. Not being future-proof or adaptable to future projects is a big problem, especially at Epic, because if I knew now what I knew then, things would obviously be very different, and that's the whole point of this talk, was that when I started, I wrote the tools for Gears 3. Little did I know, 2 years from now, we were going to do a Samaritan demo for GDC, which was last year. We had no notice. We had very little notice, and we had 6 weeks to do this project, and these are the tools that we had. So it'd be great to do a next-gen body rig, a next-gen face rig, and be able to show that stuff off, but we don't have time, so we use what we have. So making sure that I could maybe the next iteration account for this type of stuff would be key. As I mentioned, Actor X, the export was very destructive to the scene. We didn't have export selected. Actor X could only export out the one skeletal hierarchy at a time. So if you're working on a cinematic that has 6 characters, you have to bake down the animation of one of those characters to the joints and then delete out everybody else. And you have to do that for every character. So as you can imagine, if you have 90 minutes of cinematics like Gears 3 did, this can take a very long time. And some poor intern got stuck with that. And like I was saying, the UI was very poorly designed. I think if any time you're having to scroll to get to more options and things like that, there's probably a better way to handle that kind of stuff. Also, the fact that you had to select a control on the character for the UI to register who to work on, there's a better way to handle that as well. And even though the setup to get a character on the auto rig was very minimal, it was actually very hard to explain to other studios. Basically, it just involved creating a bunch of locators and placing them for defining the pivots. But you had to create them by hand, name them by hand, and then make sure you place them in the correct spots. And if you didn't do any of one of those things right, the build would fail. So definitely something that I was going to look forward to doing later would be creating tools to make this whole process easier. The face rig, again, I'm not going to talk about the actual rig itself too much, but I do want to talk about kind of some of the features and some of the problems. So it works directly with the auto rig. That was the intention, is that it plugs right in, hooks up with the existing auto rig. So if there's an auto rig made for a character, the face rig is made for that character as well, and it all works together. And the main basis of the face rig was that we wanted it to be fast and easy to transfer to every other character. We had 27 characters that needed facial rigs. And again, you could write a script that just creates controls on joints, but we also wanted the animation team to be able to do their job quick. Posing individual controls is very slow and time-consuming, and so we wanted to develop a rig that was fast for them to pose, fast for them to work with, but also could transfer to other characters very easily as well. And again, it had a UI, and we'll talk about that in a minute because that is a show. Basically, the UI that you can see there is, I guess it's pretty, you could say, maybe, but it's far from being ideal for functioning. For every character you had in the scene, there'd be a tab for that character, so you can see there's a Marcus Summer tab up there. For every character tab, there'd be 5 sub-tabs, tabs that were like character pickers, the morph target slider shapes, all this stuff. So if you had 6 characters in your scene, you're looking at like 30 tabs to click through, and that's insane. What I'm showing here is a little bit of how the rig's working. So on this tab, I'm sliding these sliders, which is actually controlling morph targets on this cage. And the cage has a bunch of locators constrained to the surface of it, which you can kind of see there a little bit. And underneath the locators are controls, and then the joints are constrained to those controls. So the idea is that you could animate a morph target on this cage that fits the model. That translates into joint animation, and by making a new cage for a new model, we can transfer our face rig very quick and easily. But the animators are actually just posing these morphs, and then they have some offset controls to work with as well. So this accomplished being fast and easy to animate, but again, the biggest complaint here is that the UI is cumbersome. It's 5 tabs for every character, and it's just not the ideal thing that they would want to work with. And keep in mind, too, that at the time, when I started, Epic had 3 animators, I think, 3 or 4. And since then, we've like tripled in size. So getting feedback back then, this was a group of hardcore game animators that had been there for a long time, and they're just used to like doing their own thing. So having a tool in general is like a hurrah for them. But as we started hiring more and more film animators especially, they're very used to having things very, very structured. And so it was actually really great getting their feedback for the next round of tools to improve on this stuff. So again, problems, the UI was even worse than the auto rig. So many tabs, so much clicking, so much scrolling. It's just terrible, terrible design. Again, I like to think that UIs are one of the artsiest things I get to do in my day because I get to make pretty little Photoshop pictures sometimes. But at the same time, there's a difference between making something pretty and making something actually usable for those guys. And at the end of the day, the animation team is my customer, and if my the old adage, the customer's always right, is especially true for character riggers. If, I exist there to make sure that their job is smooth and easy and as effective as possible. Setup was even harder to explain to other studios. It was a simple concept, but it was so hard to explain, I never even tried. I was embarrassed to even send it to Chair for Infinity Blade or anything like that, because I was like, I just don't want to have to deal with all the emails I'm going to get, and I would get a lot if I did this. So that was definitely something I wanted to address as well. And you could transfer the rig very easily, but the skin weight still took a lot of time. So 27 characters, each one, we spent about a week of skin weighting and corrective morphs. So that's 27 weeks per character, or 27 weeks total for all the cinematic face rig characters. And that is just a really a lot of time. And I had ideas to tackle this problem, but it was far too late in the project to actually implement any of these ideas. So we'll get into that in a little bit as well. Oh, and again, it wasn't very future-proof. The Samaritan demo, for example, that we did has the same face rig that Marcus has in Gears 3, because you could scale down by just not weighting certain joints, but you couldn't scale up because that would require refactoring all the code, and it was just too much of a pain. If you're interested in the actual rig itself, I did a talk on that last year, and you can find it on my website under the blog section. You can't really miss it. But I was happy with the rig. It's just some of the usability things could definitely use some work. And the last tool that I wanted to talk about was the weapon locker. And the weapon locker is a pretty simple tool whose sole purpose is to kind of mimic how weapons work in our game. So the animator can import in a weapon from the list down there, choose a hand that they want the weapon to go into on the character, and then it would attach that hand. The problem here was that all of the entries in that list were hard-coded. So anytime I wanted to add a new weapon, I had to update the script, check it in, make sure that the animators got the latest script, and this leads to a lot of potential problems. It was the same way with the auto-rig picker as well. When those guys, anytime I wanted to add a character, that was hard-coded, had to update the scripts, send that out, make sure everyone got the latest. If they didn't, problems ensued. Unhappy people were unhappy. And so this was something I wanted to address as well. The weapon locker was an interesting case, and this is actually the main reason I'm bringing it up, is because there's two problems, the hard-coded issue, and also the fact that it needed constraint offset information. So every time we import a weapon and we attach it to the hand, some weapons, to mimic what happens in game, had certain orient constraint offsets. And so those were hard-coded, and that kind of made sense. But if I was going to change the first problem to not be hard-coded, I needed a solution to also make the second part not hard-coded as well. And we will tackle that in a minute. So that was just a real quick overview of some of the tools that made up that pipeline. And honestly, I think this is probably some of the most important slides about the lessons learned, which is that hard coding is always bad. There's always a better solution. With MelScript, you're kind of limited in a way because you don't have as many operating system functions where you can go and find files and things. They do have like internal var where you can go and get your user scripts and user preferences, but making dynamic paths is a little bit tougher. Poor script structure, as I found out, having multiple scripts always being loaded in to build something can really slow down your tools, and it can also make debugging very difficult because instead of opening one file and going to the line that the error came from, I now have to open up a file, find the line, and then say, oh, actually, that's not where the error came from. It came from this file, and then that came from this file, and then I'm just going all over the place trying to find where this error came from. So it slows down me, and it slows down the animators as well. And poor planning is probably like kind of the biggest no-duh, but it's also the hardest thing because I think being able to plan intelligent tools kind of just comes with experience. There's not a lot of resources out there to say, don't do this, make sure you think of this. And that's really why I wanted to give the talk, is because if someone had told me 3 years ago, 4 years ago, these are some things you want to watch out for, you might run into outsourcing, and if you hard code your scripts path and you send this to another studio and they don't have that path, they don't have that D drive that you have on your machine, what do you do? So those types of things, and especially because at Epic, we just announced a mobile game today. We also have our UE4 high-end tech demo. We've got our current gen stuff. We've got Fortnite. We have games that cover the entire spectrum of like tech limitations. And making tools that seriously need to fit all of those is very difficult. So poor planning led to solutions that won't hold up over time. For Samaritan, I actually had to write new versions of the scripts, modified versions of the scripts to meet that project's needs, which meant that if we were to do that now with 3 projects going at the same time, I'd have to be maintaining 3 sets of scripts that were pretty much the same, but had different specifications for that project, and that is a nightmare for me, as well as for those guys and the animation team. And this goes hand in hand with what I was just saying, was that trying to think of a way to future-proof your tools so that you don't have to write the tool 2 or 3 years later again. You're not going to run yourself out of a job, because in 2 or 3 years you're going to find other needs that you need. But rewriting all of the tools that you wrote before because you didn't quite think about things that you should have thought about, there's no reason to do that if you can follow these mistakes that I made and not make them. One of the great things that happened after Gears 3 was that we found out we were going to go do a campaign DLC. And I think pretty much across the board at all the departments at Epic, I can really only speak for our animation department, but it felt like this was a great time to try new things. We knew a lot of the problems that we had, and we went through and we addressed all these things. I talked to the animators, got their feedback, and it seemed like we've got 4 months here. We could redo all this stuff, try new things, and see how it works. And if it doesn't work great, then okay, not too much time lost, but at least we don't have to wait 3 years to see if those results worked. So any short type project is a great time to try new things. It is a lot of work because you have such short time. You really have to put a lot of time right up at the beginning to make sure you get that stuff ready for those guys, but it worked out really well for us. And that short project lifespan means that you get to see the turnaround of those results much faster. Gears 3, it's like I had to wait 3 years to see how do those tools hold up. And even if I could see a problem a year in, it's like, well, it's too late. Like the wheels are in motion, I can't stop it, and this is how it needs to be until we're done with this project. And so for ROM Shadow, I rewrote all the tools in about a month because that's about the time I had before animation needed to start working. And obviously that was not a 40-hour week, per week month. That was probably 80-hour weeks. But it was like a necessity, and I think I knew what was coming down the pipe after we got done with DLC. I knew we were going to start working on Fortnite. We just announced today our new Infinity Blade Dungeons title for iOS. I knew we had the GDC demo, so I knew I had 3 projects I had to worry about after this was done. And so I wanted to make sure I wrote tools that were going to accommodate for those. And those were all over the spectrum, from the super high-end next-gen stuff to mobile. And I also switched to Python because MelScript is great. It's really great inside of Maya. But Python can do so much. It can do everything that you can do inside of Maya. It can do stuff in the API. You can write any kind of program you want with Python. So it's a very powerful scripting language. And if you're not using it already, you really should, because it's not actually that difficult to get into. I found it pretty easy to start learning. I think the syntax is very clean. It's very easy to read. And before we go on to the evolution of the actual tools, I wanted to take a moment and go over solving hard-coded paths in Lisp because it was such a prominent issue that I had, and switching to Python fixed a lot of these problems. By switching to Python, you get a bunch of OS functions. Specifically, you can get access to the OS module, which gives you access to environment variables. So one of the things I like to do now a lot is create an environment variable called Maya Tools. And what I do is I have a directory underneath. I just have a folder called Maya Tools, and underneath that I have any kind of information my tools need. So I could have a folder called Poses, and that's where all my pose library tools are stored. I could have scripts, icons, I can have face rigs, weapon locker, all that stuff can be underneath this. And then all you have to do is send that to anybody. They can put it wherever they want on their hard drive, and then use the environment variable and set their path to wherever they put it. So now all the tools work for those guys. There's no hassle about hard coding the path, knowing which hard drive mapping they have, all that kind of stuff. So environment variables are very useful for solving hard-coded pathing. So here's a little bit of a kind of a snippet that solves both problems. So by importing the OS module, we can say that our directory is equal to the environment variable value of Maya Tools. I know that in that Maya Tools folder, there's a folder called projects, so I can append on that path. And then I can use the listdir function to list all the contents of projects, which is going to return to me folders like Gears of War 3, Fortnite, GDC demo, and things like that. And then for each of those, for project and projects, I can go ahead and just add each of those to an option menu. So now I've solved dynamic paths, and I have dynamic lists that can be populated. So if I want to add a new project, all I have to do is add a new folder in that projects folder. Next time I run the script, the new project's now in the option menu. And I brought up the weapon locker specifically to talk about this problem, which was I had these hard-coded constraint offsets that were different per weapon. And I could solve now the fact that I don't have to hard-code their entries in the list, but how do I deal with their constraints? And what I found was there's a lot of ways to do this. You can have data files like XML or text or whatever, but you're still having to kind of generate that stuff and store it somewhere. One easy thing for a solution like this is to use custom attributes. So you can create a custom string attribute on, say, the root join of that weapon. That's going to store all your constraint info. So I can create a string attribute called constraint info, add in the information I need by setting the attribute on that. And then whenever I import that weapon, I can check to see if the attribute exists. And if it does, I can get the attribute and then do what I need to do with that data, which would be, in this case, set a -90 offset on the on Z on the orient constraint. And so custom attributes have been a really good way to kind of solve that problem. If you're ever importing stuff and you need to get data for it that's specific, that's a good way to handle that as well. So now we're going to go into rewriting the auto rig. So originally, mail script, tons of files that were always being imported in, caused it to be a very slow build time. Now I was going to write it in Python and keep everything in one file. So yes, that file is going to have 2,000 lines of code, but at least it's all going to be there, and it should increase the build time as well. One of Python's biggest strengths as well is that it's an object-oriented language. If you're not familiar with that, there's lots of good documentation on that stuff. But so in the constructor of the class, I'm actually writing the UI that's going to pop up for the user to select the project, the character, and then build the rig. So this is a look at like what happens when you call the constructor of that class. It's going to bring up this UI. So already I've got a option menu for projects. So now the user can select which project. So because we do work on so many projects and we are such a lean company, a lot of times all of us are working on multiple things at the same time. So now if you're working on the Gears 3 DLC, you can go to Gears 3 DLC, choose the right character underneath that, and then build that. And when you hit the build function, it actually calls on another procedure that just in turn calls on all the other procedures in order. And all those are self-contained so that we can just kind of comment out whichever procedure we don't want, and then that's a good way to debug things as well. But it's very clean and very fast. So here's a look at how the new auto rig played out. So you can choose your project, When you do that, it updates the option menu for your characters. You can choose the character. And notice that the build time is literally like 2 or 3 seconds now compared to the 40 it was before. I'd like to think that's because the script structure was a lot more planned out, because nothing else really changed except how I wrote it. The UI now docks directly into Maya's UI. It's no longer a floating window. It's one page. Everything's very compact. That was mostly in part because I had lots of animator feedback back and forth, designing something that would be useful for them. And every tool they need is in that little 400 by 600 window there. So again, much faster build times than the original auto rig. 2 seconds to 40 seconds. It's definitely faster now to build the rig than it is to open a file. Because our animation team had pretty much tripled, I had a lot more feedback. I was able to go to those guys, ask for feedback, get a lot of useful information back. With the UI, much cleaner, much more user-friendly. That's entirely part to the fact that those guys were able to give me the feedback that I wanted to make sure that they could use the tool and it be useful for those guys. And so I went with a lot of 2D mockups first, in Photoshop, passed those around for a couple days. And even though the schedule might not allow for that, it totally should, because one of the things I'm always struggling with is convincing people I need more time. 2 more days to make sure that this is right is going to save us 2 months later when I have to rewrite all this stuff because I did it wrong this time. And so that extra little bit of time going back and forth with those animators really paid off, because now it's a tool that they actually enjoy using. And again, it docks into Maya's UI with the dock control command. I'm usually not a big fan of floating windows, especially with character pickers, because they're so big that having that kind of dealing with that, figuring out where to put it, even if you put it on a second monitor, now you're having to travel too far to get to it. And I wanted to make sure that they had everything they need at their fingertips, very, very close by. So dock control is a really cool command that they implemented in 2011, I think. One of the things that the original AutoRig did not have was namespaces. I've always shied away from namespaces because they were kind of a pain, especially with an AutoRig. If you're building a rig with namespaces, you have to write a bunch of code to deal with what happens if that namespace exists. What happens if you add namespace _1, and now you have to keep iterating on that integer. It's a big pain in the butt, but the day that it took to write all those codes to handle those exceptions was totally worth it, because now what the UI does is it takes all the namespaces under the root namespace and uses those as a, there's an option menu in the UI of all the active characters. So it puts all those namespaces up there, and now the animator can just choose who they want the UI to work on. They no longer have to select a control to tell the UI who to function on. It's just an option for them. And it's far more future-proof now. We can add projects on the fly. It knows how to deal with those new projects. And we're constantly, as we've been working on Fortnite and the newly announced Infinity Blade Dungeons game, we're constantly like, I'm updating these things to even allow for more project-specific things, like what bones do you want to export out for your animation? Mobile has a much reduced list than Gears of War 3 did, so coming up with additional tools to support that kind of stuff. But adding a new project is literally as simple as going into the projects directory, creating that new project, and then when you relaunch the UI, the new project is now in the option menu. And that's all there is to it. There's no need to ever touch this UI code again. It's self-sustaining. It will work until the end of time. And then adding new Maya files into those projects for the characters, again, they'll just repopulate. I don't ever have to update that code. It's completely done, and it's actually, as you saw with that little code snippet earlier, it's not a whole lot. It's really, really simple, a lot easier than dealing with hard coding every entry. And again, one of the things I talked about was it was easy to set up. It was very minimal setup, but if you missed any part of that, it would break the build. And so I thought it'd be a good idea to actually write some tools to support that. Chair, who does Infinity Blade and Infinity Blade 2, we actually started trying to unify all of our companies to use this tool set, which was my idea, but then I instantly regretted it because I was like, crap, these aren't, on the setup side, it was always just me, and now I'm handing it to an animator at Chair who I'm having to explain like, yeah, I know it's weird and you got to add these locators, but that's how it is. So I wanted to make sure that I address those so that I'm never embarrassed, to send this stuff out to other people, especially outsourcers and things. So now I can send that stuff out, not have to support them because it's all pretty self-explanatory. And I guess it was, 6-8 months ago, our Unreal editor worked with Autodesk, and we got FBX as our proprietary import and export format into our engine, which meant that we can now use export selected, which means we don't have to bake all the character animation down, delete everybody else out. We can just export each one, export selected, much faster, much less destructive. And the editor can actually export animation data and stuff back out as well. So we can now export out animations from the editor that we have lost because Gears is now a 10-year-old project. And back when it was Gears 1, small company, people didn't check things into Perforce and things like that. So now we can actually get some of that stuff back, which is great. So we can export now without destroying the scene. We can export multiple characters very easily, and it's much, much faster than ActorX. And then in the character UI, there's actually a little export button. And what that does is when the animator clicks it, it looks at the scene name, and it looks at the time range, and it gives them an FBX with that data. If they shift-click it, they'll get the UI that you see there that actually allows them to specify that stuff. And that was meant to be like, there's a fast export, and then you can do a specific export if you'd like. So here's a look at the character setup tools. Not a very pretty UI, but it's very simple. It's 5 steps. Each step has a description and a button. And the first step gets everybody in the exact same T-pose. That way all the characters are in a unified pose. This is a character from the upcoming Fortnite game. And then the next step creates a bunch of locators, already named correctly, and it just tells you in the description where you should put them. And these are basically defining where the hand roll pivot is, where the foot pivots are for the heel, the toe, and the sides of the foot. And also you're defining the height of the character. That way, if you're making a small character, it can get the scale factor from that and then create the controls appropriate to the size of the character. And after you're done placing these locators, you can hit the mirror locators button so that it mirrors them over to the other side, groups them all up. And then the fourth step is selecting all the geometry and hitting group geometry, which groups it up and names it correctly. And then lastly, it just asks you for a character name. And once you do this, it's going to create a container, bundle up all the assets into a nice container, clean up your scene, and now that's it. So with under a minute, you're ready to set your character's actually set up for the auto rig. So now you can save this out into the appropriate project folder. And the next time you run your auto rig UI, he'll be right there in the characters list. So I can go to Fortnite. There's the new guy that I just added. And if I hit build, a few seconds later, we'll have our new player. So in under 2 minutes, we can now set the character up. I can send this to anybody. It's intuitive enough for them to know how to go through the paces. There's really no way to mess this part up anymore. So the next thing is the face rig. Now, I didn't actually change anything on the actual rig part of it, but I talked about that skin weighting still took 27 weeks for Gears 3. I had ideas, but we were too late in the project to actually do this stuff. So we actually, again, we got the character art team on board, and we said, hey, we have 9 character heads for this DLC project. Would you guys be willing to try the universal head idea? And they agreed, and so what the universal head idea is the modelers made a head with the vert count that they liked and the topology we liked, and then all other heads for that project were made from that head with the exact same vert count and same vert order, which means they're essentially morph targets of the universal head. And that means that we can actually weight the universal head, bring in the morph target of the new character, crank it up, and export out the skin weighting data from that new world position of those verts. So skin weighting now is literally a 30-second task. And as you can see in this video, so this is our universal head topology that we got, and this was all skin weighted. And then anytime a new modeler makes a new character model for off of this head, we can just import that in as a morph target, add it as a morph, crank it up, And then we can see how that works. So this is Baird with the universal topology. And then we've got young Jace from the DLC as universal topology. And also Ty from DLC. Now, all these still have the weighting because, obviously the skin cluster is at the top, so we can still extrapolate all the weights from this. So if you look at the lip weighting there, as we morph between the characters, it stays exactly like it should. So we've now maintained all of the weighting for all the characters that we had for DLC. So literally in a week, I got all the models, had all the skin weighting, all the face rigs done, and out to the animators. Before, that would have taken 9 weeks. Again, having these tools be very easy to set up to get a character on the face rig was important, again, so we could send this out to outsourcers, we could send it out to other studios, sister companies, and things like that. And so I wrote some tools for that process as well. Similar stuff where we've got a UI. The first step brings in these 4 pieces, what I like to call a cage. And the only goal here is to fit each one of these to the model as best as possible. And you can either move, scale, rotate those verts, you can use deformers, it doesn't really matter. The end result just needs to match the model as best as possible. This process usually takes about 10 minutes. For this, I just kind of roughed them in so that they're pretty close. This process is actually defining where the joints are going to go as well, and you'll see that in a little bit as well. When you're done, you can hit the build final cage, which actually takes all those pieces and makes them one solid piece. That piece can then morph into the face rig cage you saw earlier, and that's how we're going to start getting our joints and getting our face rig information. You do have to place a couple locators for non-surface details like the jaw pivots and the eyelids and the eye, and that walks you through that as well. And then once you've done placed the eye locators, you can actually mirror those over to the other side, so you don't have to worry about that. And the last step is going to build the face rig. It's going to ask you to name the character, and then it's going to do a whole bunch of stuff, which we'll cover here in a second. If you do take a look at the outliner, though, you'll notice some of the contents in there change after this is finished. For a second, you saw some red spheres show up. That was actually the face rig being brought in, and there's a bunch of stuff that happens there. And then what you have left is there's another skeletal hierarchy in there, and that's the face joints that were gotten from that process. So what that last button does is it imports in the base face rig file. That face rig file is just the initial cage with the locators, with the controls, and some joints that are all constrained. So if you make a morph target and you move that cage, all the other stuff follows. So it imports it into your scene. It uses the cage that you fit it to your model as a morph, and it turns it on. From there, we can extrapolate the joints from their new positions, create the face hierarchy that we're going to leave behind in the scene, and then we export out your modified face rig with the morphed into your new character position out to the face rigs folder with the name that you provided in the prompt dialog. So what used to take me 10, 20 minutes to open up all these different files and import things and then export things and all this stuff is now completely automated within a few seconds. Now you can take that face skeleton that it leaves behind, import it into your hierarchy, bind it to the joints, and then import in your skin weights that you got from the universal head. So that whole process to get the joints, which also gets you the face rig, and the weights is about 15 minutes of work. And lastly, because I did complain so much about the UI, and I think the animators, they're very nice. They didn't actually say anything bad to my face, but I did go in and do a much cleaner UI, lots of animator input again, 2D mock-ups to make sure that it was a tool that those people would be very glad to use. It's a single page again. I took 5 tabs, simplified it down into one page. It slots into the docked AutoRig UI as a tab. There was a pose library tool in the original one that I got rid of because it turned out the animators just like using shelves and passing those around. So there was no point, especially since I had such a tight deadline, to support a tool that no one was using. So here we've got Barrick from Gears 3. And in the AutoRig UI, we can hit the Add Face Rig button, and it goes and finds Barrick's face rig, adds it in, and hooks it all up. The face rig controls and the joints are in the exact same position because the joints came from that process before. As you can see, the UI slots in as a tab. It's not very pretty, but it's functional. And so what used to be 2 tabs for those morph target shapes are now just 2 buttons at the top and bottom that give you an empty group node with a bunch of the attributes that they can use in that channel box down there. And then the offset control picker is there in the middle, and then all the tools they need are down there as well. So again, it's not something I'd put on my portfolio as how pretty it is, but the end result is that they needed something that they could do their job more efficient with, and this is what they decided, would allow that to happen. So there's 2 new tools that were pretty essential, I think, in the new pipeline. The Cine setup batcher, if anyone's ever used Matinee in Unreal, what it does is it takes a text file from Matinee, which gives us who the actors are in the shot, what animations they're playing, when they're playing them, what cameras, when those cameras are cutting, and all that stuff. It takes all that information and takes in an FBX file from Matinee, which gives us the character positions and also the cameras. It also takes in a directory of FBX files that the cinematics team originally imported in to create their layouts, and then it takes an output directory. And what the tool does is it recreates that Matinee shot by shot in Maya with all the actors in their right positions, with the camera correct, and the frame ranges all correct, with the animations all correct. And yeah, it does it very fast. Before, on Gears 3, we had, again, an intern, poor guy, that had to do this manually, and it took him 30 minutes per shot. And we had 90 minutes of cinematics. Some cinematics could have 60 to 70 shots. And so animators, that was actually a bottleneck because animators are having to wait for their shots. This tool could usually do a cinematic on average in 30 minutes. I think the worst case we had was 60 minutes, and that was a cinematic that had 60 shots. But it was significantly faster. We could actually batch all of them in one day and get everything that the animators needed, so they weren't held up anymore. Because those guys really are the ones that were more pressed for time, because they always have so many cinematics, they're such a small team, and they have a whole lot to do. And then when the tool is complete, it goes and submits all those submitted files. It submits them all to Perforce in the correct spots so that I don't have to do that, no one has to check all that stuff. It's just there for those guys, ready and waiting. There was also a Cine export batcher, as the name suggests. This was for exporting out the cinematics to the engine. So we have I don't know if this is a pretty normal pipeline for cinematics, but ours is our cinematic teams create a layout in Unreal. We then recreate it in Maya and then polish it, make it awesome, and then re-export it back out and update everything that they've done. And so this is very simple. It just takes an input directory of all the Maya files that they want to export, and then they specify where they want those exported to. And then it goes in, and for every file, for every character in that file, it's going to export out an FBX animation. If they've just done polish on one particular file and a couple characters in that file, they can check the use as file checkbox, which will populate the below list with the characters in the shot, and they can select which ones they want to individually export. So this is so much faster than the Actor X, because with Actor X, we had 6 characters. Again, we'd have to delete 5, bake everything down to 1, export it out, reopen the scene, delete the other 5, and we had to keep doing this, and it would take forever. So this was a much faster method of getting our cinematics back into the game. One of the things, this is the last thing we're going to talk about, one of the things I wanted to add was Perforce integration. And I know that there are tools out there that allow Perforce to integrate within Maya, but I wanted to kind of expand upon what they could do. So I use the P4 Python module, which is from Perforce itself, and it's a nice Python module. And I wrote some basic functions like check in, check out, add and submit files. That way the animator can kind of just stay in Maya. They don't have to go outside of Maya. They don't have to deal with Perforce. They can stay in Maya and do anything they need to do right there. Every time they open a file, it checks to see if it's in the depot. It checks to see if they have the latest. If they don't have the latest, it gives them a prompt that asks them if they want to sync to the latest, which it will do for them, and then reopen the file. It also, and this is the biggest thing I wanted to add, is it checks any connected files, any textures, any references. Since all of our animated shots had all the rigs were referenced in, I want to make sure that if they opened up one of their shots, it would check to make sure that the rigs were always the latest, and then it would automatically sync and then reload them as well. So really all this is for trying to make those guys on the cinematic pipeline much faster and much more efficient. We had, I think on the ROM Shadow, I don't know, 15 to 20 minutes of cinematics, but only 6 weeks. And so they had very little time, and we wanted to achieve really high quality results. So we switched to referencing the rigs. We had gotten rid of that initially because, again, dealing with namespaces and things like that can be a bit of a pain. But we brought it back because the wins and the conveniences were so much, it was really worth doing. So the process for that is instead of the animators building the auto rig, what I do is I build it. I use a script to strip out all the namespaces, and I save that out as a new file. The Cine setup batcher is going to then look for those files. So it looks at that text file. It says, barracks in this shot. It goes and checks the folder where all the rigs are and says, okay, I found a barrack. Let's go ahead and reference him in. Again, the Perforce Integration makes sure that those guys, anytime they open a shot, they're always going to have the latest referenced rig. And that allows them to work quickly and achieve the results that they wanted to achieve on the deadline that we had. And so this is kind of the big hurrah at the very end, where we can kind of see how all this stuff that we've gone over kind of fits together. So again, I'm going to get the mesh from Max. I'm bringing it in with FBX into Maya. I use the joint mover tool to place all the joints. I do the skin weights. And then I can do the auto rig setup and build the auto rig, strip out the namespaces, and save that out to a new file. At this point, the animation team can use the Cine setup batcher to batch all of their cinematics out so they can start working. Because that Cine setup batcher is going to reference in all those saved out files that I made, I know that I can update those files later and they'll have those changes. They can start animation at this point. Now I can go back and do all the face rig setup because I know that they've got body rigs, they've got mocap, they have work to do for at least 2 or 3 weeks, so I've got some time to go back. So I do the face rig setup, which gets me my joints and my rig. Then I get my skin weights, import those in from the universal head. Then I can do the auto rig setup again, build the auto rig, this time adding in the face rig from the UI. And I can save over the original file that I saved out, which is also being referenced in the files that those guys are animating, which means the next time they open a file that's being animated, now it has a face rig. They don't have to do anything, it just is already there. Then when they are done, they can use the Cine export batcher to export all their animations into the editor. So that is how all those tools, everything fits together to make, I think, what we've had probably the best pipeline yet, especially for ROM's DLC. If you haven't seen ROM Shadow, I've got a quick trailer that we can watch, because I need a drink. There we go.
Rated M for mature.
War ain't always about fighting. Sometimes it's about knowing when to turn tail and run your fucking ass off. Storm's about to hit.
This is it, people. Saddle up. You know how to use that thing, kid?
Ink blocks the sun. Once it's dark, krill kill everyone.
So yeah, the animators did an awesome job. I mean, the whole team did a great job because I think we had 4 months total to work on all that stuff, and I think they did a really great job. So that is everything. I hope that was informative, and I hope most importantly you guys learned from my initial mistakes. And when designing any tool, really just try to think about any of those things.